Good day to everyone. This video I'm going to discuss about the subject special electrical machines unit 4 permanent magnet synchronous motor. In that the topic of discussion is self control of permanent magnet disc synchronous motor. So the another method which is used for controlling of speed of permanent magnet brushless sine wave motor is the self control method. The first control method is the vector control method. So in this method, the speed of permanent magnet synchronous motor is controlled by feeding them from variable frequency, voltage and variable frequency current. The rotor position sensors are employed here for the operation in self-control mode. The induced voltage can be used to achieve the self-control. This is the schematic diagram of the self-control. And the main advantage of self-control is that it ensures that for all operating points, the armature and the rotor field move exactly at the same speed. It is expected that the armature and the rotor field move in synchronous for all operating points. When there is a change in rotor speed, proportionally, the armature supply frequency also changes so that the armature field always moves at the same speed as the rotor. With the help of rotor position sensor, the accurate tracking of speed is realized by the armature supply frequency. When the rotor rotates in certain predetermined angle, the firing pulses of the converter are varied. This firing pulses of the switches is proportional to the speed of the controller. The torque angle is varied electronically, so there is an additional controllable parameter possessing greater control of the motor performance by changing the firing pulses of the semiconductor switches of the inverter circuit. So at high power levels, the current fed by the DC link converter is employed. During the commutation at low speed, the DC link current is pulsed by phase shifting the gate signal of the supply side converter from rectification to inversion and back again to rectification. When the current is zero, the motor side converter is switched on to a new conduction period and the supply side converter is then turned on. The time required for the motor current to fall to zero can be significantly shortened by placing a shunt thyristor in parallel with a DC link inductor. If the current zero is needed, the line side converter is phased back to inversion and the auxiliary thyristor is gated. The DC link inductor is then short circuited and without affecting the motor, the current can be supplied. The auxiliary thyristor is immediately blocked when the line side converter is turned on. This method of motor current interruption reduces the effect of pulsating torque. So this video we have discussed about the self control of permanent magnet synchronous motor. Thank you everyone.